Hi Year 12 Maths General students. This lesson is from Unit 3 of the General Maths program and we're looking at using an Excel Scatterplot and calculated correlation coefficient to identify the nature and strength of associations between bivariate numerical variables. So the objectives today, we're going to look at how to interpret a scatterplot, to identify and describe the association between numerical variables. And then we're going to look at how to calculate and interpret the correlation coefficient, or R value, to measure the strength of a linear association between two numerical variables. So we're going to look at the Casio calculator and Excel methods of doing this. So we need the skill of being able to describe any potential association between our explanatory and response variables when we're looking at the data. We have to be able to use the correct terminology to describe the patterns we're seeing. And we're looking at three main things. So we're looking at the form, the strength and direction, and the possible presence of outliers. When we look at the form, this is essentially looking at the shape of the association. And for the purposes of Maths General, we just need to identify whether the points are linear or non-linear if we were to look at a trend line through the points. If we have a look at these two examples, we can see that this first one has a curved trend line, if I was to draw in a line, so it's non-linear. And if we looked at the second example, I could draw a straight trend line through those data points, and that's a linear form. Moving on to strength and direction, what we're looking at is how varied the scatter of your points is from the linear or non-linear trend line pattern you've identified. And we use the word strong, moderate, weak, or there's no apparent association. And we'll look at some examples of that shortly. Another statistical feature we can use is known as Pearson's correlation coefficient, or R value. And that can be a mathematical calculation we can use to classify the strength of a linear association. So what do we need to know about the correlation coefficient? It's used to measure the strength on a scale of -1 all the way up to 1. R has a positive value when there's a positive association and a negative value when there's a negative association. And the closer the R value is to -1 or 1, the stronger the association or correlation is between your explanatory and response variable. Sometimes we'll see it written in this format. So for example, if I was looking at a correlation between a response variable of weight and explanatory variable of height, I'd write it like that. And I might be told that it's 0.8, and thinking about the value of that, that's quite strong because it's close to the value of 1. Now we have calculated the correlation coefficient using this really horrible formula that we find on our formula sheet. However, for the purposes of this lesson, we don't need to deal with this formula, thankfully. The other thing we looked at was how to calculate the R value on your scientific calculators. If we have a look at how to do that, just as a refresher, once you've entered in your data, we go to the statistical functions. Remember, we find that underneath our option 5 reg, and option 3 is our correlation coefficient value. One of the main focuses of this lesson though is looking at how we calculate the correlation coefficient on Excel. And we're going to look at how to use this correl function by revisiting the example we looked at last lesson when we were looking at the association of height and arm span. Before we move on to looking at how to do this in the example though, We need to know how to talk about the associations we're seeing within graphs. So what are we looking at when we're looking for a positive association? Well, if our points drift upwards from left to right, we have a positive association. And depending on the spread of the points, we can visually say it's weak, moderate, or strong. And you can see that all three of those examples have a positive association happening there. If it drifts downwards from left to right, then we say there's a negative association. And you can see again, we can have a weak, a moderate, or a strong. They all have that downward negative trend from left to right. If we have a random spread of points, like in this last example, there is no trend, and we therefore conclude that there is no association between the two variables we're analysing. You can also see associated with these graphs are a range of R values that when you calculate the correlation coefficient, you can use these as evidence to support your claim of a weak, moderate, or strong, or no association between the variables you're analysing. So for example, if I had an R value of 0.8, like we looked at before, that would support a strong positive association, and your graph would look something like this because it fits within that range between 0.75 and 1. The last thing I need to be wary of once I've plotted my point is the presence of outliers. So these are simply points that look like they don't belong with the rest of the points. So having a look at this graph here, this one looks like it doesn't belong, so it could be a possible outlier. And when you're calculating the correlation coefficient, you cannot include outliers because they will skew the result. Moving on to calculating the correlation coefficient in Excel, it's super easy. Essentially, just write somewhere in your table where you want to display your correlation coefficient, and we'll look at how to do that shortly in an example. And the little coding you'll use is the equals correl. The cell will then ask for your first array, so select the cells you want in the column with your explanatory data, put in a comma, then select the column containing your response variable data and close your brackets by pressing enter afterwards, and it's that easy. Okay, so we're going to try to tie all of this together using the examples we used last lesson. The first one was the 20 people sampled on their arm lengths and heights. I'll get you to open up the Excel spreadsheet that you saved. If you didn't save it, just open up this one here and quickly regraph a scatter plot. And what we're going to do with our scatter plot is visually describe the strength, direction, and form. Okay, then we're just going to look at how to quickly calculate the correlation coefficient using that correl function. And lastly, classify the strength based on the accepted values. And does this agree with your visual assessment? Okay, so if you've forgotten how to do a scatter plot, select both columns that you want to graph, insert, scatter, and then do the things like adding in your axes, titles. Remember to change your scale, you select the scale you're changing, go to format axis, and change the minimum and maximum. Click on the other scale, do the same thing. Okay, remember to add the trend line in, linear, display equation on chart, move it if you want, bold it, and we're ready to go. Okay, I'm then going to just move this over so I can do a quick calculation for our R value. So I'd expect to see something like this on your Excel, where you're making it very clear what you're calculating. Start by typing in equals and our correl. You can see it wants to complete it for us, so you select it, and it wants us to select our first array. So that's just our set of data. So we want our explanatory variable. So I'm going to press Shift to select that column. Use a comma to then move on to selecting your response variable, data. Close your brackets, press enter, and it spits out your correlation coefficient. Now, don't get this confused with the R squared that appears on your graph. This R squared is something called the coefficient of determination, which we're going to look at in the next lesson, and how to apply that value as well. Looking at our correlation coefficient and how can it support the trends we're seeing in our data here. If I was to describe the data, I would say that it has a definite linear trend, and the trend line seems to fit that nicely. In terms of the form that we're seeing in the scatter plot, we can see a nice linear trend, and our trend line supports that. So all the points of data don't vary too much from that line. In terms of strength and direction, strength looks pretty strong, and direction going from left to right is positive. Now, a correlation coefficient backs up our claim that it's a strong correlation because it has a value of 0.95618, which is quite close to 1. Finishing off answering the question, I've just pasted across the graph as well as the correlation coefficient. So for A, we confirmed it was a strong correlation, positive and linear. And one thing I didn't talk about before was the fact that it doesn't appear to have any obvious outliers. For part B, the correlation was 0.956 rounded to 3 decimal places, and this value supports our claim that the association is strong, as this is quite close to 1, which agrees with our visual observations. Your turn now. So consider the second study again, where we looked at different doses of pain medication and the time it took for the headache to go away. So using the scatter plot you composed last lesson, describe the strength, direction and form, and if there's any possible outliers. If you didn't save that graph, then quickly recreate a scatter plot. It's a great revision process anyway. I've included the Excel file there. Then once you've done that, calculate your correlation coefficient using your correl function and use that to classify the strength and direction based on your correlation coefficient value. So press pause, have a go, and we'll check in. How did you go? Hopefully your scatter plot looks something like this. Nice open scale, trend line, and the R squared values put in, labeled axes, nice title, and your correlation coefficient should be negative 0.68933. Okay, so time to do a little bit of analysis. Based on the strength, it looks moderate to me. The points aren't terribly close to the line, but you can still see there is a linear trend there. So direction is negative from left to right, and form, as we said, looks linear. The correlation coefficient is negative 0.68933. So we'd round that to 3 decimal point places to negative 0.689, and that correlation coefficient value also verifies our strength and direction. So because it's a little bit less than 0.75 and more than 0.5, it's moderate, and it has a negative value, so it's a negative correlation. Okay, so you should finish it off writing something like that, and we're done. Thanks, Year 12s.